Hey guys, welcome back to another tutorial in the series of creating Tetris within Minecraft, which is teaching you guys game logic. Okay, now where we left off last time is sort of thinking in code and answering these questions centered around the algorithm that will clear the Tetris rows for us. And where we left off is trying to figure out what kinds of data do we need for this algorithm. Okay. So let's think about that. What are a lot of things that we mentioned in here as being needed already? Well, one is a scan drone for scanning. We can call it scan drone. And that's going to be used for, testing materials at particular locations. It's going to be used for moving these chunks of blocks down when we need that. So we're definitely going to need that. Another thing that we mentioned is efficiency. So we want to not have to, let's say, move this, we don't want to have to move every single block down above a particular row clear. We just want to move the blocks that are actually there. So we're going to have a way of determining and asking if an entire row is air, and we're going to stop there. But we're going to have to mark that location so that we have a way of telling telling the process that actually moves the blocks down when to stop, or how many rows it needs to move down. Okay, so that's going to be called our ceiling. All right, and it represents, how many blocks we need to perform the moving blocks down. Okay, now the next thing is going to be the distance to move each block chunk down, and that represents the space that's between here, between each row clear. So in this case, it's the space is 2. In this case, the space is 1. And since there's actually sometimes where there's multiple spaces, we actually need a list. So we're gonna make that a list, we'll call it distance list. Okay. Now the other thing we're gonna need is the actual row index for each beginning row clear. And that's also going to be a list because we have, in this case, for example, we have a multiple row clears that are delimited by this chunk that was not cleared. Okay, so those are the main variables that we're going to need to perform this. So if we had, so let's try to envision, like, what does the actual data look like in this case? What would the data look like in this case? So, and this will actually help us when we're sitting down to write it. So in this case, I think let's try to guess what is in the distance list. So distance list is a list that contains, let's see, what does it contain here? The first occurrence is going to be at the bottom, so it's going to be a distance of 1, and then the second occurrence is going to be the second index in the distance list. It's going to be 2. So this is what our distance list is going to contain. Now the row indexes are going to be, if we're counting 0 as a row, which I can't remember if I'm doing it offhand, doesn't really matter too much here, then it would be 0 and then 0, 1, 2. So the row list would actually contain 0, 2. Okay? Alright, so the other things, scan drone, that's going to contain a drone for scanning. We don't really need to visualize that. But how about ceiling? In this case, what's the ceiling? Well, it would be the index of this value right here. So it'd be 1, 0, 1, 2, 3, 4, 5. So the ceiling would contain 5. Okay, and you notice I'm using like um, the logical operator just to say that these statements here are true in this case. Okay. Okay, so that's what it would contain. So if we knew all of these pieces of information, we could then actually perform this algorithm pretty well. Because we would look at the first indices of our lists, which correspond to each other. Or actually, no, remember, we're doing the last one first. So we're looking at the last indice of each list, and we're removing it. So we're actually going to be removing that last index and putting it in sort of a temp variable. So we would end up with, when I say temp variable, it would just be a current distance and a current row. Something like that. And I don't remember if I actually used the current distance and current row, but just for the sake of this example, that's what these things are going to store. And they're going to be integers. Integers. Okay, so we pop off, it's called popping off of a list, meaning you actually remove the last index from each list, and we would end up with 2 and 2. So this means that we're going to call our move rows down function with a distance of 2 and a row index of 2. So that means we're going to move some drone up 2 plus 2, and this is going to be the target row that we actually move down with a particular distance, the distance being 2. So we would end up bringing down these, boom, and then we would perform a repeat where we pop the last index off, which is going to be the only remaining index, off of these lists, which is going to end up giving a current distance of 1 and a current row of 0. And that's going to move, the first thing we're going to do is move the cursor drone up the current row, which is 0, plus 1. So our cursor drone is going to be right here. This is the first row that we moved down. And then our ceiling is going to actually, we're going to figure out how to use the ceiling to only move down these 2 rows. So these would end up coming down like that. All right. All right, cool. So that should give you a pretty good idea of the algorithm in more detail. Now, between now and the next tutorial, what you guys should do is code up a couple of functions for me. Okay, and one of them is going to be being able to answer how do we know when to clear a row. Okay, so it needs to take a scan drone as a parameter, and then it needs to return true or false based on if the entire row is air, or sorry, when the entire row is solid, when the entire row is not air. So if you run into air, you need to return immediately false. So if a row is to be cleared, that's what I named my function. The row is to be cleared, then it returns true. If it's not, then it returns false. Okay, now another function that you guys should be able to do between now and the next tutorial, and when I say you should be able to do it, I just want you to attempt it, and if you run into any problems, that's fine. Just watch the next video where I'll go over the code and we'll test it. But the actual function that I want you to do is one that tests the exact opposite. So if a row is air, if a row is completely air, then you need to return true, otherwise return false. Okay, so we'll have those two separate functions there, and then so we'll look at those and then we'll test those. Actually, we can skip testing those, but we'll just review those and then we'll start reviewing the moving down in the consequent videos.